Okay, I would say that your test will be, I honestly don't think your test is as hard as your quiz in terms of like, the difficult level of like types of times that you see a GCF or, I think there may actually, well, I don't know how many factoring problems there are, but because there are other things on there, you have to solve by factoring, you have some word problems, so
Oh, not word.
I think that there are other things that you will need to consider. Nick?
Yeah.
Put your phone away.
Oh, Nick.
Okay. So, first one on here, pretty simple, straightforward one. C squared plus 3c, subtract 28, trinomial, so I'm going to factor c squared, what's that going to factor into? C and C. And negative c value, so what does that tell me about my signs?
They're opposite.
Opposite signs. So I need to find factors of 28 so that it will OI to 3.
Negative 4 and 7.
Negative 4 and positive 7. And I don't have to solve here. There's no equal sign. It's just factoring. So that's what you should have had for 1. Questions, concerns on that one?
Oh, shoot. I had 7 and negative 4.
Which, yeah, that's fine.
Oh,
What do you mean? You had C plus 7 and then C
Yeah.
minus 4? Yeah, that's fine. So if your
Yes.
factors are in a different order, if you have C plus 7
Okay.
and C minus 4, that's correct.
Okay.
Okay, it's just in a different order. Good? On the next one, what do I need to do first?
GCI.
Divide by 2b.
2b.
B.
Yeah. So I can divide everything by 2b. Does that 2b disappear?
No.
No, because I have to remember that it's the opposite of multiplication, and if I were to multiply it back out, I want it to end up the exact same thing that I started with, so I don't want the 2b to disappear. What would that leave me with?
12a squared.
Oh, no.
11a squared.
11a squared minus
6a
minus 5. So now, can I factor what's left here?
Yes.
So 11a squared must just be 11a and a, and then again I have a negative c value, so I have opposite signs. The only factors of 5 would be 5 and 1. So 1 positive, 1 negative. How am I going to place factors of 5 so that it will OI to 6? Negative 6.
Plus 5 minus 1.
Plus 5 minus 1. So that I get negative 11a, positive 5a. That adds up to negative 6a.
Wait, what do you do with the 2b again?
It's just going to stay out front. That's my GCF.
Okay.
So here's my final answer. Okay, make sure you're correcting your work as you go or filling in problems that you left blank for your homework, because this is your study guide. When's our test?
Next class.
Next class. Okay.
Could the positives and negatives be switched in that case?
What do you mean? Like if it was negative 5 and positive 1?
Right.
If it was negative 5 and positive 1, it would OI to positive 6. Okay. So that wouldn't work. Okay. Okay, next one. D squared. So I got D and D. First time we've seen a positive C value. What does a positive C value mean?
Signs are the same.
My signs are the same. Does that mean both my signs will be positive?
Nope.
No, what does it mean?
Negative.
Negative.
Why are they both negative?
Because it's a
Middle
negative.
value is
negative.
negative.
Because my middle term is negative. So I will have a negative, negative. And I need factors of 36 that will OI to 12.
6 and 6.
Negative 6.
Negative 6 and negative 6, so I'm done, right?
No.
Who said no? Aaron, why am I not done? It's the same parenthesis twice. D minus 6, D minus 6. So I could write that simpler by just saying D subtract 6 squared. Full credit right here. Okay? So if you have the same parenthesis twice, you should write it as 1 parenthesis squared. What do I need to do first on the next one? Divide everything by 5, GCF. So I take out a 5. That's going to leave me with 2x squared plus 7x plus 6. And then I'm going to factor what's left. The 5 doesn't disappear. 2x squared becomes 2x and x, positive c value. So that tells me my signs. Oh, you can't see it. Not really.
Oh.
What are both my signs going to be?
Positive.
Positive, because my middle term is positive. And what are factors of 6 here that will make this OI to 7?
6 and 1.
But I have a 2 out front. So it's not just about the factors of 6, it's about the combination between the factors of 6 and the 2x and x. 3 and 2. So that's going to give me 4x and 3x, and that adds up to 7x. Good. What can I do on the next one? By 2?
3.
6?
Oh yeah, 30.
Okay, so if I divide it by 6, that's going to leave me with 4x squared minus, what? 25. So then am I done?
No.
Okay, so I have 2 terms. What's the only way I can factor 2 terms further?
They're both perfect squares.
If they're both perfect squares,
Do that.
and if they both are if there's a difference between them, meaning subtraction. So if they're both perfect squares, and if it's the difference of those perfect squares, then it factors into the sum and difference of their square roots. So what's the square root of 4?
2. X.
2x and 2x, and the square root of 25?
5 and negative 5.
Yeah, I'd have positive 5, negative 5. The sum and difference of their square roots. Okay, difference of 2 perfect squares. If I have a squared minus b squared, it will always factor into the sum and the difference, oops, ran out of space, of their square roots. If you get stuck there too, I told you another way that you can think about that is if you run into 2 terms and you get stuck and there's no middle term, put in 0x and then see if you can factor it from there. How can you factor 4x squared and negative 25 so that it will OI to 0 in the middle, and you'll end up with the same thing. This OIs to 0 gives you negative 10, positive 10. Okay, right away when you see 4 terms, what's the first thought that should go into your head? Yeah, you should immediately think I should group them. So I group 2 terms and I group 2 terms. What is the GCF that I can take out of my first 2 terms? I can divide out an x squared.
Yes, ma'am.
So I have an x squared term that goes out front. What does that leave me with? X minus 2. What is the GCF I can divide out of my other grouping? Jack.
Oh, 4.
4. And I'm taking out a positive 4, so I'm going to write that sign. If I took out a negative 4, I would write minus 4. I'm taking out a positive 4, so I write plus 4. That leaves me with x minus, are you all right?
No.
Minus 2. If you grouped correctly, I will end up with the same parenthesis twice.
Right.
So I can divide out the x minus 2. And what does that leave me with? X squared plus 4. And then you want to look and see, can I factor anything further? I cannot, by the way, factor this x squared plus 4 further, because even though they're perfect squares, it is a sum of perfect squares, not a difference of perfect squares. And there is a difference between addition of perfect squares and subtraction of perfect squares. So this is done. This is my final answer. Okay. And the last one on the front page, you have 4x squared plus 64. What can I do with this one?
Put the squares.
I can divide by 4. And if I divide by 4, that gives me 4, and then x squared plus what? 16. And then you feel like you want to do the difference of two perfect squares.
But it's not negative.
But it's not subtraction, so I'm actually done. I can't. This is my answer. All that I can do there is take out a GCF. Don't let it fool you. Okay, this is addition here. Okay, if I have addition between two perfect squares, I cannot factor it any further.
So tricky.
So tricky.
It's not even nice. They're just tricky just to front.
And by they, you mean the person who typed this sheet, which would be me.
The mean math teacher.
The horrible person who typed up this sheet.
Probably Scott, wasn't it?
Probably.
Probably Mackenzie.
Yeah. Okay, so on the back, we have solving by factoring. So it says solve for x. So on the test, not only will it give you those directions, but you know that you have to also solve when you see an equal sign. So I have 2x squared minus 6x plus 4 equals 0. I now have an equal sign. That tells me that I have that additional step where I will factor it, just like I factored on the first page, but I will also then need to set each factor equal to 0 and solve. Before I factor, I have to make sure that my actual equation is set equal to 0. My first one is set equal to 0, so I'm all set to go. I can factor. Oh wait, Mrs. Sawyer, stop. Why should I stop?
GCF?
There's a GCF. Let's take a 2 out. What would that leave me with? X
X squared minus 3x
plus 2. And then I can factor what's left, which would give me x and x, positive c value, negative middle term.
Negative 1, negative 2.
Okay, so there's my factoring, but now how do I solve? First of all, does the GCF even matter?
No.
No. Okay, the only time the GCF matters when I'm solving is if there was an x here. If there was a variable here, then I need to consider it as one of my factors that I need to set equal to 0 and solve. But I don't need to consider it here. Here I just have x minus 1. I'll set that equal to 0. And x minus 2 equal to 0. I take each factor, set it equal to 0, and solve. What are my two solutions?
X
1.
equals 1, and then x equals 2.
And x equals 2. Okay, so that one extra step, factor, then solve. What then does that graph look like? What does that graph look like?
A parabola that's.
Oh, the parabola's line.
It looks like a unicorn's chin. It's like a
What?
A chin?
Why only a unicorn's chin? I mean, doesn't a parabola look like everybody's chin?
Just a unicorn.
I just don't.
I
just don't
It looks like, doesn't your chin look like a parabola?
No, because like unicorns go like way out and they come back in. This one's just like.
That's
Well,
ridiculous.
everybody's chin is different, you know.
Everybody's, okay. Okay, first of
Everyone's
All of that.
It did. The timer's still going. The timer's still going.
Okay, I gotta pause. All right, so what did x equal?
Unicorn.
1 and 2.
1 and 2. So what does that mean in terms of my graph? What does that mean in terms of my graph? X equals 1 and 2.
We're gonna pass the negatives, right? No.
Opposite side.
Parabola crosses the x-axis at those points.
The parabola crosses the x-axis at 1 and 2. That's a horrible parabola.
Wait, I didn't know about.
The parabola crosses the x-axis at 1 and 2. So you want to have that understanding. We're not quite to graphing yet, but when I talk about solutions and intercepts, one and the same. Okay?
How far down do we need to, like go?
Intercepts.
Will there be any?
We don't know that yet. We're going to get there. We're going to talk about that. That's
Will there-
next unit.
is it
That's
gonna-
called the vertex point. We're not
Will there
there
be
yet.
any parabolas in the test?
I may ask you to then
Oh, wow.
draw a sketch of the graph based
We
on
learned
based on
parabola
your
in
solution.
Right.
Oh, we're doing it right.
Yeah, that's
Not
only
more
2
than
days
20
this
minutes.
year.
So,
I'm gonna have to study for a minute.
if I have 3x squared minus 4x equals 4, first of all, what's the very first thing you need to do here? Yeah, I can't factor this without setting it equal to 0. So how would I do that? Subtract 4. That's going to give me 3x squared.
Is all
3x squared minus 4x minus 4 equals 0. Then I factor, just like we factored on the front side of the sheet. Nothing's different there. So I have 3x and x. I have a negative c value, so I don't know my signs, but I do know that they should be opposite signs, one positive, one negative. Factors of 4, so 4 and 1 or 2 and 2, and I need to place them so that it oys to 4. 2 and 2, and if I oi here, I see that I have 6 and 2, so if I make this negative 2 and positive 2, that's going to oi to negative 4. You see that? But I want to solve, not just factor. So I will take each factor and set it equal to 0. I will take 3x plus 2 and set it equal to 0, and I will take x subtract 2 and set it equal to 0. Over here, quick and easy, add 2. X equals 2. Over here, I need to subtract 2, negative 2, and then divide by 3. Exactly, x equals negative 2/3. So what does that mean in terms of my graph? It's crossing at negative 2/3 or negative 0.67 and positive 2. So this graph, if I were to draw a quick sketch of the graph, I said x equals negative 2/3 and 2.
That's an X.
Yeah. And 2?
Yeah.
So 1, 2, and negative 2/3. So not quite at negative 1 and 2. My parabola is crossing at negative 2/3 and at 2. I'm going to skip the next one. You're not going to have one that difficult for solving. Is there a GCF there?
Yeah.
Let's not look at that one.
Which one? Oh.
I won't look.
Let's look at the next one.
Bottom left.
X squared equals 5x minus 4. When I solve, I don't want my x squared term to be negative when I factor, really is what I'm saying. So I don't want to subtract x squared. Instead, let's move our 5x and our negative 4. So that, when I rewrite, will give me x squared minus 5x plus 4 equals 0. Does that make sense? Because I'd subtract 5x and add 4 to get it set equal to 0. And then that is what I will factor. When I factor that, x and x, what will it factor into?
Oh, minus 1, minus 4.
Okay, so what are my solutions?
Oh, x equals 1, x equals 4.
Good. X equals 1, x equals 4. So if I were to graph that, 1, 2, 3, 4, 4,
6 times.
and 1, there's my parabola. Okay, quick sketch of my parabola. And I'm going to skip to the last one. which is 2x cubed plus 11x squared equals 6x. What do I need to do first?
Put it in standard form.
Yep, subtract 6x. What do I have going on here? Is there a GCF?
X.
I can take an x out of everything, which will give me 2x squared plus 11x minus 6. And then I can factor what's left. So that gives me 2x and x. Factors of negative 6 that will weigh to 11. Six and 1. Where does the 6 go? Where does the 1 go? 6 here. 1, so positive 6, negative 1. It's going to give me 12 and negative 1. So when I solve here, notice, and we talked about this before, this is a cubic. That means I have 3 solutions. The GCF that I pulled out is a variable. So this becomes one of my solutions. I need to take this GCF and set that equal to 0, or that factor and set it equal to 0. So one of my solutions is x equals 0. Here's my next factor, 2x minus 1, set that equal to 0. And here's my other factor, x plus 6, set that equal to 0. So my 3 solutions, because it's a cubic, so I know I should have 3 solutions, would be 0, x equals a half, add 1, divide by 2, and x equals negative 6. Okay? If my greatest exponent value is 3, then I should have 3 solutions. Okay? So if you encountered, say for example, a grouping problem on solving that your largest exponent value was a 3, you should anticipate having 3 solutions in your answer. I didn't put any, Okay, so on your review, this is the last application problem. It says the width of a rectangle is x plus 3 feet, and the length, million typos, of a rectangle is 2x minus 5 feet. If the area of the rectangle is 90 feet squared, find the value of x. So, first suggestion here would be to draw a visual when you encounter a problem like this. So we have a rectangle. The width of the rectangle is x plus 3 feet. And the length is 2x. Subtract, 5.
Oh, wait, what problem are we on?
We're doing the review. We're on the review.
We're on the review right now. Yep, we're on the last one of the review, and then I'm going to move to the modeling page.
Oh, I thought that was
And the area is 90 feet squared. So I'm doing the ones that are most similar to what you'll see next class. So how do I find area of a rectangle? Length times width, base times height. So I'm going to end up having 2x minus 5 times x plus 3 equals my area of 90 feet. Does that make sense? So do we know how to multiply 2x minus 5 times x plus 3? Do we have those skills? Yeah, distribute. So take 2x, distribute that, and gives me 2x squared plus 6x. And then take negative 5, so then I get negative 5x minus 15 equals 90. Or 2x squared plus x, subtract 15 equals 90. So now is this starting to look kind of more similar to those solving problems we just saw?
Yeah.
So how would I, if I want to now factor to solve, I need it set equal to,
Minus 90, so
I need to subtract 90, so I gotta get it set equal to 0. So I get plus x subtract 90 would give me negative 105 equals 0. So now I need to factor my new trinomial that I just created. So I have 2x and x. And I want to look at factors of 105.
Numbers like 105 be on the quiz or?
No, it won't be this large of a number. So I could have, let me list off some factors of 105 for you. So you could have 3 times 35. You could have 5 times 21. You could have 7 times 15. You know you have opposite signs. And you want it to oi to 1. I see 1 here that will work. 7 and 15, yeah. Because it's not about just these numbers, right? Like I'm not looking across here to see which one will add up to 1. It's about the combination of that and the 2x and x. So if I place 7 and 15 here, and I put, let's see, positive 15 and negative 7, that's going to give me negative 14x and positive 15x. That adds to x, okay? So then when I solve for x, just like we solved above, 2x plus 15 equals 0. That's going to give me x equals negative 15 over 2. Would I have a negative length? No. I totally ignore this answer. I would not have a negative length. That's not the answer I want. I want this answer. X equals 7. That's my answer right there. That's the one I want. 7 what? Feet, okay. So it just asks me to find the value of x. X equals 7 feet. Okay. What if it asks me to find my length and my width? I would take 7 and I would plug it in, right? Okay. We don't have time for it, so I'm not going to do it right now. I want to at least, at a minimum, show you the setup of the next one, okay? So the next one that I have is from your quadratic modeling one, and we didn't get to it last time. So I have a triangle. It gives me different lengths. I have x plus 1, x, and x plus 2. Do I know something about the relationship with a right triangle and the side lengths and the hypotenuse? And what do I know? What's an equation that I know? Yeah. What is that? Yeah, Riley, you're all set. Yep. A squared plus b squared equals c squared. Exactly. So what would that look like? Let's see. Well, my side lengths, x squared plus x plus 1 squared equals my hypotenuse squared, x plus 2 squared. So those of you who have been making that silly mistake of distributing that exponent in all semester, you're going to be in trouble here. Because x plus 1 squared, that means I have x plus 1 times x plus 1 here. And x plus 2 squared means I have x plus 2 times x plus 2 here. Okay? So it looks really like we have to blow this out a little bit, but it's actually going to clean up pretty quickly. I'll have x squared plus x times x gives me 2x plus 1 equals x squared plus 4x plus 4. And then as I go to clean this up, if I subtract x squared, that's going to take away an x squared on each side. And then let's see, if I subtract 4x and subtract 4, that's going to give me x squared minus 2x minus 3 equals 0. And now I'm down to factor status. I can factor it and solve for x. Okay, so things you may see would be a problem like this, Pythagorean theorem problem. and maybe a rectangle type problem. That makes sense? We'll have a little bit of review before your test, and it won't take up the whole class time, I don't think. You should be prepared to show a little bit of graphing information, kind of link it to that next unit that we'll be thinking about starting before vacation. Yes, Isaac? Just study, 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 study.
Hey, Miss Sawyer, how long is it?